So what we're going to talk about in this video is how to determine the probability of finding an electron in the L equals 0 to L over 4 region of a particle in a box, right? A 1D particle in a box model when n is equal to 2 in those cases. So there's two approaches that you can do it. One is more of a qualitative approach where you just simply plot out what the wave looks like, and then you can kind of get a good sense of it. So if we do that, right, well, all we have to do is we can plot it out. And if we draw out what the wave function looks like, right, we're going to have, right, if n is equal to 2, we're going to have a node right here in the middle. So you're going to have one part that goes up, and you're going to have one part that goes down. And so, right, we're going from 0 to L, right? So L is the length of the box. And so we know that the node is going to be at the L equals half point. And so then L equals over 4, right, is going to be this point right here, right? And that's going to be, where the maximum is of that wave right there, right, of that peak right there. So what we're looking at is simply this shaded region right here, right, from 0 to 4. And so if we look at it, right, we can easily segment out and break apart our wave function, right, initially into halves, right? You're going to have one half where everything is essentially positive right above it, and then you're going to have one half that's all the way below it. And so, if you were to go from, 0 to L equals 1/2, right, then you have a 50% probability of finding the electron there, right, because it's, half of the region, and so you have all of that right there. Now for L equals over 4, right, what you're doing is you're essentially going from 0 to that first peak, and so you're going half of the half in that case, right, and so half of half is a quarter, right, so there's a 25% chance, right, of finding an electron right there. And we can just simply do that again qualitatively by looking at the plot. If you're being asked to do it in a more quantitative matter, right, you're going to have to do a little bit of calculus because you're going to have to do an integration. So if we write out, what the equation is for the wave function of a 1D particle in a box, right, it's going to be the wave function is equal to square root of 2 over L times the sine of n times pi times x over L, right, where n is the principal quantum number, pi is pi, x, right, is the position over L, right, which is the length of that particle in a box, right? And so the probability is just simply the wave function squared. And so what that comes out to being then is 2 over L times sine squared times n pi x over L in that case. So what we can then do now is we can just simply integrate that equation, right, in reference to x, and integrate it right over from 0 to L over 4. So if we take the integral of that whole system, right, what we're going to have is 2 over L times, right, and then on the one side, right, you're going to have the x over 2, right, minus L times the sine of 2 pi n x over L over 4 pi n in that case, right, minus, right, so this is going to be, the second x position, right, so that will be the L over 4 for our case, right, minus x squared over L, or sorry, not over L, over 2, minus L times the sine of 2 pi n x, right, the starting point, right, over L over 4 pi n in those cases. And so all we have to do now is just simply we can plug in the values that we have, right, for the different x positions where we're trying to integrate from starting to end of. So that's going to simply then be, right, 2 over L is L over 4 over 2 minus L times the sine of 2 pi, right? And we can plug in our 2 value now, right? So that's 2 for our n. And so then we have L over 4 over L over 4 pi times 2 minus, and now, right, we're going to have 0 over 2, right, because we're at the 0 position starting off, minus L times the sine of 2 pi times 2 times 0 over L, all of that over 4 pi n in those cases. So one thing we can see right here, right, is that the sine of 0, right, is 0. So all of this right here doesn't matter, right? And then 0 over 2 is 0, right? So this doesn't matter as well. So the only thing we have to really worry about is this part right here. Now, in this case right here, right, we can see that the L's are going to cancel. So we have 2 times 2 over 4, right? So what we get then is 1. And so the sine of pi is also equal to 0. So that right there all cancels out. So the only thing that we really have to worry about is this part right here. And so what we get then is 2L times L over 8, right? Because we're doing L over 4 over 2, so that gives us L over 8. So we do that, we can see that the L's cancel out. So we end up with 2/8, which is the same as 1/4, which is what we did qualitatively earlier. In that case, right? So we see that the probability of finding an electron between 0 and L over 4 is going to be, a 25% chance, right? You're going to have a quarter of a chance there in that case. And so that's how you approach it, but either qualitatively or by, applying calculus and integrating over that region.